As we continue to talk about quadrilaterals, we're gonna focus in our attention onto parallelograms, and parallelograms are nothing more than a quadrilateral with different properties. So, what properties do all parallelograms possess? And as we prepare for parallelograms, we need to review back to lines cut by a transversal, and more importantly, parallel lines cut by a transversal. So right here we can see that we have parallel lines Q and S, and they are cut by transversal R. And we want to remember those specific relationships that we had. We have corresponding angles, alternate interior angles, alternate exterior angles, and then same side interior angles. So with this, we talk about corresponding angles. Starting there, let's see, corresponding angles. An example of corresponding angles would be, as I look, corresponding, the same general location. So when I look at this intersection and I look at this intersection, for example, angle 1 is at the top left, and angle 5 is at the top left. So those would be corresponding angles. Angle 2 is at the top right. Angle 6 is at the top right. So they are corresponding because they're in the same general location, the same corresponding location. So I know that that angle 2, it corresponds to angle 6. So for an example, angle 2 and angle 6 are corresponding angles, and I know that corresponding their relationship, they are congruent. Now, let's see here, alternate interior angles. Those are angles where interior, okay, so interior means that they're looking between our two parallel lines. That would be interior. And then alternate, so they're talking about alternating sides of our transversal. So interior, an alternate interior angle would be 5 would be interior, and then 4 would be its alternate interior angle. So there you go. We have 4 and 5 are alternate interior angles, and those two are going to be congruent. So as an example, we have angle 4 and angle 5. Let's see here, alternate exterior. Exterior angles are when they are going to be outside of my two parallel lines. They're exterior to that. And let's see, we're talking about alternate. So the same term applies there. Alternate would be opposite sides. So I could say that angle 1 here, angle 1 is an exterior angle, and then the alternate exterior angle would be angle 8. And those two are also going to be congruent. And so we have, for example, we have angle 1 and angle 8. Let's see here. The same side interior angles. Interior, again, is going to be inside. Inside my parallel lines here. And then same side, we're talking about two angles that are on the same side. So of the transversal, so for example, angle 3 and angle 5 are same side interior angles. And there we go, angle 3 is related to same side as angle 5. And those will add up to be 180 degrees, or also known as supplementary. Now, there are more examples, but I just highlighted one example to where we can remember those things and move forward as we talk about parallelograms. And it's important because parallelograms consist of opposite sides which are parallel. And that will help us. Some of the items that we are going to, properties that we're going to identify are based on what we learned many units ago with lines cut by a transversal. So as we look at the parallelogram angle theorem, what we know is that theorems, again, are things that we can prove. And so what we can say is that opposite angles of a parallelogram are going to be congruent. And I'm just going to use the symbol for congruency. And as we look at this parallelogram, we have parallelogram D, E, F, G, and our opposite sides are going to be congruent. So let's see here, angle G is going to be congruent to angle E because they are opposite of each other on the parallelogram, and then angle D is going to be congruent to angle F. That is my parallelogram angle theorem. My opposite angles in a parallelogram will be congruent. And then supplementary consecutive angles theorem in a parallelogram. So the consecutive angles in a parallelogram are supplementary angles. And that should be a period, not a comma. So we know they are supplementary. And why? What does supplementary mean? Well, supplementary means that they equal 180 degrees. So consecutive angles are going to be angles that are next to each other in order. So C and D are consecutive angles because they are in order. Angle F and C are consecutive angles because they, adjacent angles. Consecutive, they're in order going around. F and E would be considered consecutive because they're next to each other. So as we look at this, some of the things that we can identify is, well, if consecutive, I have the measurement of angle C plus the measurement of angle D is going to be equal to 180 degrees. And then as we continue to go around the circle, then I should know that the measurement of angle D plus the measurement of angle E is also going to be equal to 180 degrees. And of course, knowing that theorem that we just talked about, that opposite angles are congruent, well, look, it looks here that angle C and angle E are going to be congruent angles because their measurements are going to be equivalent. And again, we can keep going around the circle and say that the measurement of angle E plus the measurement of angle F is going to also equal 180 degrees. And finally, the measurement of angle C plus the plus the measurement of angle F is also going to equal 180 degrees. So understanding that consecutive angles are supplementary, and therefore their measurements will equal 180 degrees. These theorems and these definitions allow us to solve the problems. And if you don't know what the definitions are, it does make it very hard to work with the problems, going back to lines cut by a transversal. So again, what properties do all parallelograms possess? I want to say that we just walked through some of those, and we're going to practice with them now. So looking at some examples here, we have blank angles in a parallelogram are congruent. I think that means opposite, right? We just talked about that. So if opposite angles in a parallelogram are congruent and consecutive angles in a parallelogram are supplementary, so let's look at this problem and say they've given us that angle C is 93 degrees and they want us to find the other measurements. Okay, well, if angle C is 93 degrees, let's see, what do we know? We know that angle C is equal to angle E because they are congruent opposite angles. So then I know that angle E is going to be 93 degrees. And I know that consecutive angles, for example, C and D, if I add those two angles together, they should equal 180 degrees. So let's see here, I got angle D plus angle C is equal to 180 degrees, and angle D is unknown, but I do know that angle C is 93 degrees. equals 180 degrees. So if I subtract 93 degrees from both sides, it turns out that angle D is going to be equal to 87 degrees. So there you go. Angle D is 87 degrees, and then opposite of it would be angle F. Opposite angles are congruent. So angle F is also 87 degrees. And there you go. We're able to use those two theorems to find the angle measurements of a parallelogram. And let's see here, example 2, what are the measures of the angles of a parallelogram A, B, C, D? Well, they haven't given us a specific degree measure like they did in the last problem, but what they did tell us, they did show us that it looks like angle A is 5p plus 7 and angle C is 9p minus 13. So if we use some of those properties that we just talked about, that we know that opposite angles, right? Opposite angles are congruent. So angle A is going to be congruent to angle C. So the measurements are going to be equal. So the measurement of angle A is equal to the measurements of angle C. So just do some substitution. We have A is 5p plus 7, and that is going to be equal to C, which is 9p minus 13. Do some inverse operations. Let's see here, combining like terms, right? When I do to one side of the equations, I do to the other. That becomes 0, and I have 7 is equal to 4p minus 13. Add 13 to both sides to combine my like terms, and 4p is equal to 20. Divide both sides by the coefficient, and I found out that p is equal to 5. Okay? Didn't help me really technically. It didn't find my measurements, but I know that I have this variable that's equal to 5. So what are the measures? Well, now I just do some substitution. I know that angle A is equal to 5p plus 7. So that is going to be 5 times 5 plus 7, 25 plus 7, which is going to be 25, right? Plus 7, which is going to be 32 degrees. So hopefully the opposite angles, of course, are equal. So angle A should be 32 degrees, and angle C should be 32 degrees. But had I said that angle C is equal to 9 times P, which is 5 minus 13, which is going to be 45 minus 13, which sure enough is 32. So there you go. Opposite angles, using those theorems, we're able to come up with our solution. Let's see here, continuing on to parallelogram side theorem. So here what we know is that my parallelograms, opposite sides of a parallelogram, are going to be congruent. So let's see here. Let's change color up some here. Opposite sides of a parallelogram are congruent. Much like when we were dealing with rectangles. We'll find out later on that a rectangle is a parallelogram. Opposite sides are congruent and they are parallel. But let's see here. So if opposite sides are congruent, then I know that this is congruent to this, and this side is congruent to this side. So that's that opposite side theorem. And then if I know this, what that does is it allows me to find some values by understanding that property. If we look here at example number 3, what is the length of MN of the parallelogram LMNO? So they're asking me, what is this length right here? What is the measurement of that? And right now I don't know the measurement because they've given me a polynomial 5x plus 1, but I can solve for that x because we were just told that this side is congruent to this side. Therefore, if LO is equal to MN, then LO is 8x minus 17 is equal to MN, which is 5x plus 1. I go ahead and subtract my 5x from both sides to do my inverse operations, combine like terms, and I have 3x minus 17 is equal to 1. Go ahead and add 17 to both sides. That becomes 0. I have 3x is equal to 18. Divide by the coefficient. X is equal to 6. Well, x is not mn, but what I can do is take the value of mn. So mn is equal to 5x plus 1. Substitute in the value of x, so I have 5 times 6 plus 1 is 31. So the measurement of mn is 31, we don't know what, but 31 units. So again, using some of these theorems to solve for problems. Looking back through your examples as you are working on today's assignment, because, another property for parallelograms, we have the parallel diagonal theorem. And what that tells us is the diagonals of a parallelogram bisect each other. So my diagonals of a parallelogram bisect each other. So what does that mean? Well, the diagonal, we have diagonal AC, and then we have diagonal BD, and they bisect each other at point E. So I can tell you that if they bisect each other, that means BE is equal to EB. So BE is going to be equal to ED, and then AE is going to be equal to EC. AE is equal to EC. And the last thing that I know, that since those two bisect each other at point E, point E is a midpoint. Because it is in the center of both of those diagonals. So understanding those few things, let's see, if BD is 22, then EBE is 11. Is that right? That's true, right? Because I know from that a long time ago that segment addition postulate that BD is equal to BE plus ED. And then if BD is 22, BE is 11, what in the heck is ED? Well, ED is equal to 11, and that's doing it algebraically, right? There you go, ED is equal to 11. Or if we just know that they're congruent, this statement right here, that BE equals ED, if BE is 11, ED is also 11. Let's see here, example. So we're not just given a number. What we're doing is we are given two polynomials, but I know that I have a parallelogram, and my diagonals bisect each other. So that means that T is a midpoint. That means that RT is equal to PT, and that's what I've set up here. PT is equal to TR. And then I've done some substitution, right? PT is 12y plus 4, and TR is 15y minus 11. So in order to, what is the length of PR? We need to find this entire length right here. We could make them equal to each other to find y, and then we could substitute y back in. So if I go ahead and do my inverse operations to isolate my variable, that becomes 0. I have 4 is equal to 3y minus 11. Go ahead and add 11 to both sides because I'm continuing to combine like terms and isolating my variable. So divide by 3, and then y is going to be equal to 5. Well, if y is equal to 5, I can now substitute that back into one of my segments. And I could say that PT is equal to 12y plus 4, or 12 times 5 plus 4. We have 60 plus 4, or 64. So PT is equal to 64 units. If PT is 64, right, if this segment is 64, I know that this segment is also 64. Therefore, PR is 64 plus 64, which is 128 units. So there you go. I was able to use that diagonal theorem to solve for that. Looks like we got another example here. Example number 5. Let's see here. Example number 5. It says find the measurements of angle C and angle D. Well, right here we have parallelogram A, B, C, D. Now, I just called it a parallelogram. We know that it's a quadrilateral, but I think what we intended to give here is a identified parallelogram. So it is a parallelogram. And when I go ahead and do understand that my opposite angles are congruent. So if opposite angles are congruent, I know that angle C is equal to angle A, or the measurements of, because they're congruent. And then, so if I do some substitution, I have 4x plus 11 is going to be equal to, angle C is going to be equal to angle A, 6x minus 15. Now doing some inverse operations, combining like terms, solving for x. To isolate my variable, I will subtract 4x from both sides. That will become 0. I will have 11 is equal to 2x minus 15. Add 15 to both sides. That becomes 0, and I end up with 26 is equal to 2x. Divide both sides by the coefficient, and x is going to be equal to 13. Now, x is 13. I need to substitute that back in over here so I can find angle C. So let's see here. Angle C is equal to 4 times 13 plus 11, which is going to be 52 plus 11 is 63. So angle C is equal to 63 degrees. And I know that, what else do I know here? I know that angle C plus angle D is equal to 180 degrees. Substitute in for C, 63 degrees plus angle D is equal to 180 degrees. Subtract 63 from both sides. And then angle D is going to be the measurement of 117 degrees. So there you have it. Angle D is 117, so this is 117. And then angle C is 63 degrees. And again, C and D, the reason I did this, because if you recall, consecutive angles are supplementary, which means that they are equal to 180 degrees. Whew, goodness, one more example here and we can move on about our business. Now, let's see here. It says, given this, it says the measurement of GHF is 34, and then the measurement of HJF is 124, and the measurement of FKJ is 79, and it wants me to find a bunch of these other measurements. So what I'm going to do is I'm going to go ahead and label what we have. Label what we have here. So FKJ is 79 degrees. GHF is 34 degrees. And HJF, this entire piece right here, is 124 degrees. All right, so we can fill in some blanks here. I know that this is a straight line, so therefore this plus this should be 180 degrees. So 180 degrees minus 79 makes this angle over here 101 degrees. Now, I also know that, recall, vertical angles are congruent. So I can go ahead and fill in these and say that this is 101 degrees and this is 79 degrees. So I've gotten a couple of angles now. Now I know that if this was a parallelogram, I do know some characteristics that, you know, if this is parallel to this, then we're talking about some alternate interior angles are congruent. But I'm not going to jump to that right this second. But I do know that right here, this angle, the three angles of a triangle will add up to be 180 degrees. So I know that this angle is going to be 180 degrees minus 34 degrees minus 79 degrees, which is going to equal, and I hate to admit it, I just got the calculator out and found out that that is 67 degrees. You know, I make so many foolish mistakes sometimes when I'm making these videos. So let's see here. So this is going to be 67 degrees. Okay. Again, making some leaps and bounds. I'm going to go ahead and assume that this is a parallelogram because we're dealing with parallelograms and it should have been labeled a parallelogram. Poor on my behalf, huh? So let's see here. I know then that alternate angles are congruent. Alternate interior angles are congruent. So therefore, this is going to be 34 degrees. And that makes... Do we know what this is yet? I don't think so. But we do know that opposite angles, alternate interior angles again, are going to be congruent. So I have that. How are we doing so far? And then I know that this entire angle was equal to 124 degrees. Minus 67 degrees is going to be equal to, I want to say 57 degrees, right? 57 degrees. So this is 57 degrees. So this should be 57 degrees. And again, this angle right here should be 180 degrees minus 101 degrees, which is 79, minus 57 degrees, which is going to make that 22 degrees. And then that would make this 22 degrees. I think we have just filled in all the required measurements that we'll need to fill in our assignment here. So let's look. GFJ, GFJ, that is going to be 22, our angle sum theorem. So 22 plus 34 is going to make, this is 56 degrees. FGH is 124 degrees. Is there an FJH? I don't see not yet. Let's see here. HFJ, we said is 34 degrees. HKJ, we said was 101 degrees. Let's see here. JGH is 67 degrees. Change it up some just for the fun of it. FGJ we said was 57 degrees. FHJ we said is 22 degrees. And then finally JF is 67 degrees. Now, I went really fast by doing that, but, look back at it, absorb it, as we do those comparisons. And what we were able to do here is we were able to further identify properties of parallelograms, which are a quadrilateral, but they do have some special properties. And we were able to use those special properties in terms of theorems to solve for different items in that parallelogram. And looking back, I will tell you that today's assignment is very reminiscent, very similar to what these examples that we've gone through. And so I want you to make sure that